Hey everyone, welcome back. Today we're going deep into supervised learning and the most common models you need to know to solve real-world problems. Whether it's figuring out what category something belongs to or predicting a number, these models are your best friends. Let's start by understanding the two big categories in supervised learning: classification and regression. Classification models help you sort data into categories or classes. For example, is an email spam or not spam? Is this tumor benign or malignant? Will a customer buy your product or not? Common classification models include logistic regression. Despite its name, this is a classification model great for yes/no or multi-class problems. It estimates the probability that something belongs to a certain class. For instance, if an email is 90% likely to be spam, logistic regression tells you that. Decision trees. Imagine answering a series of yes/no questions, like, is the sender known? Or does the email contain a suspicious link? The tree splits the data step by step to reach a decision. Support vector machines. SVMs work by drawing the best possible line, or in higher dimensions, a boundary that separates categories. For example, it might find the best line to separate red apples from oranges based on features like color and size. Random forest. This is like having hundreds of decision trees vote yes or no, because it aggregates many trees. It usually gives more accurate and stable results. Neural networks. Inspired by how the brain works, these models are fantastic when you have complex data like images, speech, or text. For example, they power facial recognition or voice assistance. Now, on to regression models, which predict continuous values. Examples where you use regression: predicting the price of a house based on its size and location. Forecasting sales numbers for a company's next quarter. Estimating how much electricity you might use next month. Some popular regression models. Linear regression. The simplest one, where you draw a straight line that best fits your data points. Think of it as predicting your monthly expenses based on your phone usage. Ridge and lasso regression. These models add some penalties to linear regression to avoid overfitting. They're useful when you have many features, helping your model focus on the most important ones. Decision trees for regression. Like classification trees, but instead of assigning categories, they predict a numerical value based on splitting your data. Support vector regression. SVR. This adapts the SVM idea to predict numbers. It tries to fit your data within a tube or margin, balancing accuracy and simplicity. A quick note: some models, like decision trees and SVM, can be adapted for both classification and regression. That makes them incredibly flexible. Now let's talk about ensemble methods. Why use just one model when you can combine many and get better results? AdaBoost and gradient boosting build models step by step, focusing more on data points the previous models struggled with. Imagine a coach who helps you improve by pointing out your mistakes again and again. Random forest and extra trees take a different approach. They build many trees independently and combine their results. This approach reduces errors and prevents overfitting. These ensemble methods are famously powerful and widely used in competitions and real projects. Finally, let's talk about artificial neural networks, including deep learning models. These are made of layers of nodes, neurons, that process data in complex ways, allowing machines to learn patterns humans might miss. They're behind many modern breakthroughs like self-driving cars, virtual assistants, and automatic translation. Neural networks work great for both classification, like recognizing handwritten digits, and regression, like predicting stock prices. To wrap up, selecting the right model depends on your problem, the data you have, and what you want to predict. Knowing these models and how they fit into your problem toolbox is a huge step towards becoming a machine learning pro. In upcoming videos, I'll show you exactly how to train, test, and improve these models with real datasets. So make sure you're subscribed and ready to code. Thanks for watching, and see you next time.